Furthermore, these scientists propose a protocol for testing this idea in the laboratory using artificially produced event horizons. These results have been recently published in Physical Review Letters, Quantum Aspects of Stimulated Hawking Radiation in an Analog White Black Hole Pair, where Ivan Aguyo, Anthony J. Brady and Dimitrios Kranas present these ideas and apply them to optical systems containing the analog of a pair. Black holes are some of the most mystifying objects in our universe, largely due to the fact that their inner workings are hidden behind a completely obscuring veil, the black hole's event horizon. This entanglement is the quantum signature of the Hawking effect. This astounding result is difficult, if not impossible, to be tested on astrophysical black holes, since the faint Hawking radiation gets overshined by other sources of radiation in the cosmos. On the other hand, in the 1980s, a seminal article by William Unruh established that the spontaneous production of entangled Hawking particles occurs in any system that can support an effective event horizon. Such systems generally fall under the umbrella of analog gravity systems, and opened a window for testing Hawking's ideas in the laboratory. Stimulated and spontaneously generated Hawking radiation has recently been observed in several platforms, but measuring entanglement has proved elusive due to its faint and fragile character. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.